Welcome back. First of all, welcome back from US.
Yeah, no problem, Nadia. Yeah,
But you got
I seem to be traveling a lot lately.
okay, yeah, I guess so. US and China, all that stuff.
Yep. Yeah.
So don't. I've got several questions. If you're ready, we can start. So, what is green seal technology about, and how it differs from what was done at Atraverda several years before?
Green Seal is actually a suite of technologies built around the initial patent for a bipolar electrode, but Green Seal encompasses now many patents for different functions of a bipolar battery. We realized that to build a bipolar battery, it's not sufficient just to have an electrode. You need to have the complete battery structure and all the manufacturing processes that go with that battery structure. So Green Seal encompasses all of our patents, trademarks, secrets, know-how. It's now a generic term for everything that we do. Initially, it was applied to the initial Green Seal electrode.
And where do you produce and make these tests today? Also in UK as previously?
No. So Advanced Battery Concepts is US-based. We're based in Clare in Michigan. We have about 50 employees there now. And our facility is purely for developing new battery technologies, which we then license to the existing battery manufacturers.
Okay, great to know. So you moved.
Yes.
Thanks to which factors do you have cycle life increased by 300% compared to today's batteries, and moreover having twice reduced charging time?
Yeah, so it's a function of the structure of the battery. In a traditional prismatic battery, the active material closest to the terminal posts and the top lead works the hardest under fast charge and discharge. In our designs, the whole surface area of all of the active materials are worked uniformly. So not one small area is putting out more energy than the other or absorbing more energy. The whole of the active mass is receiving the same amount of work at the same time. And that really adds very much to the charge acceptance time, better partial state of charge compared to a standard prismatic battery. But cycle life is also driven by very uniform balance of active material, cell to cell. That's because we control our active material balance very uniquely within the industry. And also it's a function of very high compression on the AGM holding the active materials in place. So there are a number of factors that contribute to charge acceptance, higher partial state of charge working, and also to cycle life that are a function of a very good bipolar design. And I would say that any bipolar design is capable of achieving those performance improvements. But bipolar structure needs to be sufficient to withstand this increased cycle life. And that's important. That's what we do.
One more factor that contributes to this, and I know this factor, it's your expertise for last 20 or how many years of expertise have you got with this technology?
Since 2007.
Yes, because I remember that first day when I arrived to Atraverda. It was
Yes,
2007. Yeah.
it was.
Yeah.
So Dr. Schaefer, who is the founder and CEO of this company, he and I joined Atraverda on exactly the same day, May the 2nd in 2007. And that was his first exposure to bipolar lead batteries before his experience was lithium. So, we have a lot of experience in batteries and in manufacturing and commercial sales and so on between the two of us. But mainly Ed Schaefer is the principal in this organization. He created most of the technology that we're working on today.
So I've heard this word lithium. How do you think, can bipolar battery compete with lithium technology, or do they have different applications?
That's a very interesting question to ask because ultimately I haven't seen cycle data for lithium for long-term testing. And I think very few people have. I mean, we all have experience of our mobile phones and our laptop batteries. We all know the like of those. And yet the claims made around lithium cycle life and durability are very great. What I would say is that we've pushed the boundaries for lead acid significantly. Our energy densities now are much higher than in the past. So now we're up to 60 watt hours per kilogram plus, and we're targeting 70. And conventional batteries are originally around 35 watt hours per kilogram. So we've almost doubled the energy density. We've improved the charge acceptance, and all these things make us closer towards lithium performance at pack level. A lot of lithium quotations for performance are done at cell level, not at pack level. By the time you add in a case, heating, cooling, all those other things that you need, like a BMS with a lithium pack, then we become quite competitive, but of course extremely competitive on cost. We're many factors lower in cost than lithium because we're still lead-based, but we use less lead than a conventional battery. But of course, recyclability is key. And lead is 99 point something recycled. And to date, lithium has a high cost associated with recycling.
Yeah, that's right. And it was actually my next question about the amount of lead in your battery. So how does your approach reduce the amount of lead in battery, like 46%? How it works?
So a conventional prismatic battery uses lead grids to suspend the active materials, lead oxide active materials. Those lead grids form no other purpose than act as a support mechanism for the active materials and also for conducting electrons. And then those lead grids are connected at top level. Each grid is connected at top level with top level lead and brought out to terminal posts. So all of that lead is not active in the electrochemistry of the battery, i.e. it's not active in generating energy or accepting energy. It really is just a transport and support mechanism. So we construct the transport and support mechanism in a different way. We use a bipolar electrode, and our electrode is predominantly made of plastic. So conventional ABS or polypro or any other materials that are used in the battery industry today, we can make our electrodes from. So our lead content is significantly reduced because we don't have lead grids. We have a plastic support structure, and we don't have lead top lead connecting the cells together. So all of that assembly operation, all of that excess lead material that's not used in the electrochemistry is eliminated in our design. Hence 46% weight saving.
Yeah, it makes it lighter, much lighter.
Yeah. Sorry, 46% lead reduction and 30% weight saving. Bipolar is not new. It was invented in 1926, I believe, by a gentleman called Kapitsa. And Kapitsa wanted a more powerful battery. So he decided to make a battery in a different way, just having a very direct path for the electrons to flow through. The problem for Kapitsa was his batteries leaked everywhere. They leaked between the cells, shorting the cells out. The acid leaked between the two, and acid leaked to the outside environment. And that has always been the challenge with bipolar. How to stop the batteries from leaking cell to cell and to the external environment. And that's something that we've spent a lot of time on, and a lot of our intellectual property and know-how is around making the structure reliable and robust to make the bipolar electrode work finally.
Can you say that this problem is completely solved for today?
Yes.
Okay, nice to know.
Without a doubt.
Yeah.
In a very cheap, low-cost, effective, very robust manner.
Okay, great, Dan. And I know that 3 global manufacturers, they already adopted this technology, your bipolar technology, in their products.
So we have 4 licensees
already
today.
4.
So Enesis, JCI, Trojan, and Exide Industries in India.
Wow, all known names.
Yes, of course. And you may have seen recently we just signed a note of understanding with Fengfan also in China.
Yes, it was my next question. So we came to it very naturally. Thank you. So just tell me a bit about this. Do you think it's a big step forward for the technology, and why? How will your cooperation look like with Fengfan?
So, of course, I can't talk about individual customers in detail because our terms are covered by a non-disclosure agreement. I'll talk more in general. Advanced Battery Concepts has had its 4 licensees for between 1 and 2 years now. Those licensees are very well progressed with their plans for bipolar. The demand on our resources is cyclic, and as we free up some resources and ability to be able to respond, we'll bring on new licensees. And it's obvious when you analyse the battery markets, the lead acid battery market, that There are a number of key territories and a number of key players. Of course, we feel the need to be in Asia, several parts of Asia, Japan, China, Korea. And what you're seeing with the Fengfan announcement is the rollout of our Chinese strategy to bring several Chinese key lead-acid battery producers into the bipolar world with our green steel technology.
So you've conquered a great part of the world. It's Asia. Congratulations.
It's the next part of the world to hopefully make progress in.
You still have several.
Conquer is when everybody's making our batteries for everything, and today they have to make a start. So conquer is a long way off. But we're very optimistic. You know, the technology has broad applicability for different types of product lines, for SLI, for motive, for industrial, for grid, off-grid, for marine. It can be applied anywhere that lead-acid batteries are used today, but more importantly, where big lithium packs are also being used today. So I see no reason why this technology won't be adopted by many of the major players in all of the markets. But more importantly, we don't intend to license every single battery manufacturer in the world. We will license manufacturers that we believe have a very strong approach to quality and reliability and brand reputation that bring market scale to ABC. We don't want the battery companies to be in a knife fight to the lowest possible margin again. We want healthy battery companies that can develop technologies into the future.
Great. It sounds perfect. Perfect plan. And the last question, the last but not the least. I know that ABC became a member of science program initiated by ARGONNE LAB. Could you tell me more about main objectives of this program and about your role in this?
Masha, honestly, I can tell you very little about that. I don't know very much about what we're doing with ARGONNE. We have a project. We have many projects with many different labs and also many different suppliers. Of course, we don't just want to learn about our core technology. We want to expand our knowledge base. So we have many projects. I'm not familiar with the details of all of the ARGONNE Lab project. It's not something that I've been working on.
So what is the next main project, major projects that you are interested in and that you think will bring some great results to a company?
Well, we want to expand our product line away from, to include not just motive and industrial batteries. We want to expand it now to SLIs and start-stop batteries. We see a great interest from a lot of customers that are purely focused in that market, and we want to be there supporting that market. But also, we want to bring down the cost per kilowatt-hour cycle of owning a battery, regardless of its chemistry, to the point where it's cheap enough to store electrons from the grid and to distribute those electrons when needed. And that's called the levelized cost of energy storage. And we want to be in the arena where grid storage and off-grid and microgrid are all looking at our technology to satisfy a need in that area. Because that's an enabling technology. Today, it doesn't exist. Today, that's a $200 billion market that is just waiting for the right technology to come along and, offer an alternative or a solution to that problem. And we have a path to get down to less than 10 cents per kilowatt hour cycle and maybe even much lower, maybe down to 7 or 6. That becomes possible to store grid energy in many developed societies.
So maybe those 2 billions are waiting right for your technology. Let's hope so.
Yeah, it's a long path that we're on. It's not a short journey.
Yeah, so what else can I add? I wish you lots of success with ABC and with all projects you have and you will have in the future. And I believe in Asia and ABC cooperation and in everything you do, because I know you for many years and I believe everything will work for you.
Thank you, man.